Okay, let's start the lecture. Let me share the screen. Please let me know once you can see the screen. We'll share the content. Okay. What you can see now?
PERT, Doctor. PERT.
Okay, good. So today is the continuation of the previous lecture on developing network diagram. So before we continue on this, I would like to, whatever it is, I need to recap on network diagram. So hopefully, if you have any doubt, then you can ask here so we can discuss together. So I'm going to quickly recap on developing the network diagram. So I believe you remember this network information given. So what is this? What we can do by having this information? So what does this mean? Anyone?
We can construct the activity on node.
Okay, thank you, Diana. Yes, exactly. So if this is the activity that been given with the description, so the most important information that we need to take note is the preceding activity and also the activity time. So preceding activity, what's the purpose of this, guys?
The activity before the current activity.
Yes, means that it explains the steps, which start first and which come later until the completion of the project. And the activity time means that the activity or the time for each activity to be completed. So if this is the example, what would be the starting point?
A.
A. So A is going to be the starting point. After that, so we are done with A. Next.
Split to BCD.
Okay, so it's split to BCD. Why? So from preceding activity note here, we can see preceding activity A is B, and from A also C and also D. So you are right. So these are going to branch out from A. A, B, C, and D. So we are done on this. What's next?
BC merge to E and BCD merge to F.
Okay, exactly, Daniel. Thank you. So BC here to E. And BCD to F. Is it something like this?
Yes, Doctor.
Okay. Next, F. From F, it is G. F to G. And then E and G, I'm going to complete the activity H. Okay. So by understanding this, so means that you know how to construct the network diagram. If this first step activity, if you couldn't do, then you're going to, it's a total mess up. You can't continue further the other analysis. So make sure you understand how to construct this, basically by referring to the preceding activity. And this is initial, I would say this is initial sketch for you to get to know how it will, the flow will look like. Because later on you need to write in a, you need to draw, I would suggest the example in the lecture is you're going to draw a box. I mean, there are many ways and there are many type of approach that can be used for us to calculate the early start, late start, early finish, late finish. But I would suggest this by drawing the boxes, right? So you should know something like this. Okay, so usually we are going to put the activity. If it's A, then A. If it's C, then C. So where you going to put this activity time? The center here. Okay. So you're going to have a branch in, branch out, whatever it is, right? Let's say here is C. So it's branched out into 2. Did you get what I'm trying to explain here?
Yes, doctor.
Okay. So so you're going to have some information here. So you need to understand early start, early finish, late start, late finish. Okay, in these 4 boxes. Of course, in the exam or in the assessment, you're not going to give this. You need to understand. And usually here is the SLAT activity, which is the differentiation between these two or these two. Okay, so all of you, are you okay with up to this point?
Okay.
Okay, so this is just a recap. Okay, so when you draw activity on node, okay, we have activity on node and activity on arrow. Okay, so but the scope I decided to just focus on AON. Okay, so this is how it will look like when we completed the network diagram with the boxes, and this is the legend for you to clearly understand. So what we are going to do if we have all of this information, can we calculate where we are going to start? Anyone? What we are going to do? You have this, okay? Now you need to calculate the early start, early finish. So where we are going to start with? Hello?
Early start, doctor. Early start.
Yeah, which one?
We start with
What the value? Where we are going to start with what?
A should be start with early start 0, then early start plus duration equals to early finish.
Okay, thank you. So we are going to start with early start. Since A is have nothing previously, so if we start with 0 here, okay, and then 0 plus 5 is 5. And then what's going to happen? Early finish here going to be the value for early start for the next activity. Okay, so we are going to have 5 here. Does it true? Is that what you understand?
Yes, doctor.
Okay. Then what's going to happen? We are going to add again. So you have 20, 15, 10. Okay. So from this activity B, we have 20. From activity C, we have 15. So now we need to choose. We can't take both. We can't do average, but we need to choose one. Okay. Here we have 2 choices. Here is 20. Okay. Okay, that's fine. 20, 15. So you have 3 choices, 15 and 10. Let's come to this. Which one should we choose to be the early start for E? 20. Why? Why 20?
Choose the highest.
The highest, exactly. So we are doing now is we call it forward pass, right? We call it forward pass. What we are doing now, forward pass. So for forward pass, we are going to take the largest duration, 20. The same here, 20, 15 and 10, we are going to select 20. So 20, 15, 35, and you have 35 here, and 20, 10, 30, and this 30 will go here. 30 plus 170 is going to be 200. So 235, of course, 200. 200 plus 35 is 235. So we are done on forward pass. This is clear, right? Okay, so we are done 50% of or 45% of the AON network analysis for forward pass. So what we are going to do next is the backward pass. Okay, backward pass. So for backward pass, we are going to calculate the late finish and late start. So how does it work? So we are going to start with what information? Anyone? You should know this.
We start with the H1 and the H200 will be the late finish for G and E, and so on. When we calculate, we get our late start.
Okay. So here we are going to start with H, right? So early finish for here, H is going to be used as a late finish. 235. So now we are start moving backward. So what we are going to do, we are going to minus. We are going to minus 235 minus 35. You're going to get 200. Right? And the 200 goes here. And the 200 also goes here. So now you minus 200 minus 15. How many? What's the answer?
185.
1,
5, 8,
5. 200, 170 is 30. So now this is direct 30 and 185 goes here. And how about this one? So 185. Can we just write a 185? Here is 185. Okay, we have another arrow here. Okay, so 185, we need to wait outside because we have another arrow here. 30, 10 is 20. So now for this arrow, we have to choose 20 or 185. So in this case, we are going to choose
20.
20. So if you just put 185 like what I did just now, so you're going to get wrong and you're going to mess your calculation analysis later on. So it's very important to be careful and you just need to focus on the arrows. Okay, so we have two arrows, mean that you have two values to be compared. So 185, 20, the backward pass, you're going to choose the lowest duration. So you're going to be 20. So here you have 20, okay, 20. This one is 20. Okay. So now it's 20 minus 15 is 5. How about this one? 20 minus 10 is 10. 20 minus 5? 15. So can you tell me what value that we should insert here?
5.
5. So we what's the choices that we have? We have 15, we have 10, we have 5. Since it's backward pass, we're going to choose the lowest. So 5. And 5 minus 5 is 0. So now we've done about 90% of our analysis. We are done on backward pass. We are done on forward pass and backward pass. So what else? What are the things that left?
Slack.
Sorry?
Slack.
Okay, thank you. What is slack?
The time that
Delay
you
time
can
on
take relax.
That relax. Okay. Anyone want to add the explanation of your friends, Daniel, just now? What is slack?
delay time of activity as
Delay time. Yes, exactly the same time. It's same meaning, right? So it's like you have some time to plan if anything goes wrong. You know, means that the activity can be delayed up to that slack activity times without what? Without delaying the completion of total time. Okay, let's finish it first. So what should we do? So we just minus. Okay, usually we minus late start with early start, or you also can minus early finish with late finish, but we have dedicated boxes here, right? So usually we just use this box. 0 minus 0 is 0, or you can just 5 minus 5, the same. You should get the same. Okay, so here is 0, here is anyone 165, is it? 0, 0, 0, 5, 10. Okay, so we are done, right? So if I ask you what are the activities with the critical path, where is the critical path?
The activity that have 0 value in Slack.
Okay, so tell me now, what is the critical path? A,
Activity that have no delay.
sorry?
Have no delay.
No delay. Yes, but if I ask you what is the critical path of this network, what would be your answer?
A,
FGH.
B,
A,
C,
B. Oh, so it's not here.
F, A, B,
F.
F.
See it here.
B, S,
Yeah, F.
So let me
G,
change. Okay. So it's A,
B,
B,
G, F,
G. Okay, F,
G,
G, and H.
H.
So usually you can highlight or you can just bold the arrow. So it's A. So this is mistakenly done. So it's not B to E. It's A, F, then G, then H. Okay. So if we ask you what is the critical path, you should be able to say A to B to F, G, and H. So this is the critical path. Okay, so it's A to B, B to C, F, G, and H. Okay, so what else? What is the total completion time of this network?
2, 3, 5.
TC, total completion time, 235. Okay, 235. If it's days, then days. If it's weeks, then weeks. So basically it's here. Okay, the same. So this is the total completion time. So what will happen? What will happen if activity F here is delayed by 2 days?
total time will be 237.
means that it cannot be delayed. So by delaying 2 days, it will delay the whole completion date. As an example, delaying 2 days for F is going to make the total completion time maybe 2, 3, 7. But we don't know. Just don't try to say the number of this, because you need to calculate. We don't know whether it's going to give this, right? Maybe going to change something else here. Okay, so it's basically you need to explain the situation. Critical activity with 0 slack cannot be delayed. If delayed, it's going to delay the whole completion time. Okay. What will happen if activity D is delayed by 5 days?
Everything
Nothing,
still okay going on.
nothing happened.
Okay, so I understand your point. Everything is okay, but if in the assessment or in quiz, if even in the test, so you need to again explain the situation. What is this? D is not a critical activity with 10 days of slack. So by delaying 5 days or 4 days or 9 days or even 10 days, it's not going to delay the whole process. What if activity D is delayed by 12 days?
Total time will be 237.
Okay.
Although it's not a critical activity, but its delay has longer than it recommended, so the total activity will be delayed if the delay time by activity B delay time by activity D will be 12 days.
Okay. Thank you, Daniel, and who's answering just now before him. Both of you are right. You got the point. But you should explain that this is activity D is not critical by having 10 days slack, but exceeding the slack, the permissible period for being delayed, so it will delay the whole activity. Right? Did you understand now the slack? What's the purpose of slack? Which activity that can be delayed? You know, anything that you want to answer? Want to ask me on this point? No. No, everything's good. Is it okay?
Sorry, doctor, we want to ask for I want to ask for the assignment, like doctor got talk about the assignment on the last pages, sure. The last pages of the slide.
Sorry,
The assignment, asking about the assignment.
assignment.
Yeah, doctor got talking about the assignment on the last page of this side of the slide in the video, right?
Last page of this slide.
Mm.
Okay. What the slide is all about?
Is about this one, activity on nodes networks. Is I want to ask
I
is
didn't get. I didn't get it. What do you mean,
Oh.
assignment?
Yeah, the last pages, air control project network diagrams assignment that Dr.
Hello?
got taught in the video. Hello?
I couldn't hear anything.
Oh, sorry. Sorry. Doctor got talk about the assignments on the last pages on air control project network diagrams.
Okay.
So is the assignment going to be a group assignment or just
Okay. The assignment thing I will brief later on. The slides in the example slide is basically to show you the network diagram if you develop using the Microsoft project, that how it looks like. That's only the purpose of that slide. On the assignment, it's going to be group assignment, but I'm going to brief about the assignment later on. So now, make sure you got this, you understand this, okay? I have another question to, is Linda here? Linda Shazana?
Yes, doctor.
Okay, Linda, I want to ask you about activity E.
Activity E, yes.
Okay, what will happen if activity E is being delayed for 100 days?
E. Uh,
Yes, can you see? I circle it here, the box with activity E.
yes, doctor.
Okay, so I'm asking you what will happen to the project completion time if this activity is delayed for 100 days? Aha, you good answer. Why you are thinking?
The B and C will affected.
Okay, how? How it will be impacted? B and C.
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 Sorry, C. Yes.
C, okay.
The delay time will also increase.
Okay, what will happen to my question is, what will happen to the project, the whole completion time of the project?
Completion time will.
Okay, so you didn't get what we have been discussing just now. First, what you should do, Linda? You should check what's the slack amount of the slack of this activity. Do you know what is slack?
Yeah. This sebelah staff report tu.
Sorry?
Should be 100.
Sorry.
The 165.
It's not clear. Do you know,
Is it one?
What is slack?
The delay time, doctor.
Delay time. Okay, good. So what's the
Yes.
slack time? What's the slack value here for activity E?
35. Slack time is 100.
Okay. So how about, okay, wait a minute. Akmal Hakim, are you there?
Yes, doctor.
Okay, can you help Linda? What's the slack value here?
For E, right?
E.
165.
Okay, so Linda is actually 165.
Okay.
Here. Okay. So basically the difference between this and this, or this and this, the same. So 165. So when it's 165, I'm asking you, what will happen if this E is delayed for 100 days? So you say it's going to impact this. So basically, we're not going to say it's going to impact the activity before. It should impact the activities going in the future. But I'm precisely asking for the whole completion time. So you should say 100 days is within the slack. Within the slack. It's not exceeding 165. Right? It's not exceeding. So the project, this is not the critical activity with slack 165. So by delaying 100 days, it won't delay or won't impact the whole completion time of H. Thus, the completion time would remain 235. So did you get it now?
Doctor, can doctor explain again about the not exceeding?
Sorry?
The not exceeding just now that you said.
Okay. So what's the slack here? E. What's the slack?
165.
165.
165.
So what this 165 means?
The delay time.
It's not delay time. The time that you have, how to say? It's not delay time. This is the time that permissible to be, if anything goes wrong, if not going to impact the whole completion of the project if it's delayed up to 165 days.
Okay.
Okay, why? If we see logically, this activity need to wait for this activity to happen. Okay, so in this activity is 170 days need in order to complete activity G. If E is completed after 15 days, it can't do anything. Just wait here because activity after that H, right? H need both for them, so H can complete. So why we have 165 here? So what will happen if this is not completed in 15 days? They still have time until 165 days, right? So our delay just now, I said to you 100 days, okay, Linda? So 100 days, if you minus, you still have 65 days. She's not exceeding 165. If it is exceeding 165, let's say the delay is 170, okay? So the permissible delay time or the float or the slack is 165. So now it's over, exceeding 5 days. So by exceeding 5 days, it's going to delay the whole completion. It's going to make this project completed late. Did you get it now?
Yes, doctor, get it.
Okay. So it's good that I point out your name, but I don't know how about others who are keep silent. This been explained well in the previous video, and I have recapped it. So I'm done. So this is what you should know and you should understand. So basically, they are explaining about forward pass, backward pass. I have explained all of this, and then network with slack, right? So slack is here. So we are done on this. So now we are going to see the PERT. Are you ready?
Yes, doctor.
I need to wait for the answer. I don't know why it's delaying. Okay, thank you, Darwin, and I hope your answer is applicable to all of your friends too. Means that all of you are ready. So what is PERT? PERT is acronym for Project Evaluation and Review Technique. Okay. The main objective in the analysis through PERT is to find out the completion for a particular event within specified date. And PERT approach takes into account the uncertainties. The 3 time values are associated with each activity. Okay, let's go back to our network diagram. Okay, this one. We drew the network diagram just now because we know this is the activity time, right? Yes or no?
Yes.
Okay. So how we can say exactly for all this activity, this is the exact activity time to complete. How we can exactly say this activity going to be 5 days, this activity going to be 15 days, this activity going to be 10 days, this activity going to be 5 days. How we know? How we can confirm that this is exact time that we know that's going to work? Anyone? How we know this? Yes, they told us, they give this information, yes, but how we can confirm that this is the
By forecast, doctor.
okay, then,
From previous experience.
thank you, exactly. So it may be from previous experience, or you have a certain standard, you know, it has been documented, and you know by following this step, this is the activity that we know, right? So by having the exact time, so we can draw the network diagram. But in reality, let's say you want to you want to develop a network diagram for activities that you are going to explore. So that kind of approach is not always can be used. Why? Because we don't know. Is it right, the 5 days, or can it be completed earlier in 3 days, or it's going to be late, or going to take more time? So in PERT, the only differences between the network diagram previously CPM method is we are going to have 3 assumptions. Okay, what are they? We are going to take into consideration the optimistic time. Okay, optimistic time means that this is the shortest possible time that we can do. Okay, optimistic times. So usually it's denoted by TO. Okay, actually 0 here. Okay, and the second one is most likely time. Like this is maybe the most likely time, estimate of the normal time. Assumes normal delays, you know. So this is denoted by TM, most likely time. And we also going to consider pessimistic time. What is pessimistic time? Represent the longest time the activity could take if everything goes wrong. And this is denoted by TP. So you can read the other details later on, but this is the point. So we are going to consider these 3. Okay. Okay or not? I need to wait for you. Anyone to answer? Okay. Okay. So in PERT calculation, all values are used to obtain the percent expected value. So by considering all of these 3, okay, you need to consider all of these 3 to get expected time. Okay, or we can call it average time, or what else? Median time, I don't know. Basically, it's expected time, okay, or average time. So this is the formula using a beta distribution. So this is the formula. What is this? This is expected time, okay, that we are going to find. You are going to be given the each time, right? You're going to be given 3 information for each activity. So you need to find the expected time. So what is this?
Optimistic time.
Optimistic time. Optimistic time plus 4 times most likely. Okay, so they have a coefficient of 4. 4 multiplied by the most likely time and plus pessimistic time. And you get the average. It's 6. 1, this is 1, this is 1, this is 4. So 6. So you're going to get X, and this is the expected time. Okay. And additionally, later on, you also need to find variance. Okay, before we go more, I would like to know, have you done with your statistic class?
Yes, we have.
When?
In our second semester, first year, I think.
Okay, so I don't know. So you are done with it. So basically, I no need to explain about variance and blah blah blah, right? So you need to calculate the variance. Okay. So basically, what is the variance? Pessimistic minus optimistic. Okay. What is pessimistic? The longest, right? Longest time. Okay, longest time. Minus optimistic, shortest time. So basically, it's a different between the largest and smallest, and you are going to divide by 6 and square. So to get the variance. You got it, right? So this is the example of the expected duration. Okay, so you are going to be given this, all of these three. Previously in our class session, it was only one, right? Maybe this, right? Most likely, I don't know. They even not specify me. But we got only one, so we can easily just go for constructing the network diagram. But now you've been given optimistic, most likely, and pessimistic. So this is the same thing, the activity. So you need to identify the mean duration. So do you want to try this? So help you here with the formula. So we need to plus with 4 times of most likely time. So 6 plus 7. And you're going to get the average. So you're going to get this value. Okay, it's going to be 6 here. And you need to calculate the variance. Okay, so as we know, the largest minus the smallest, or the pessimist minus optimist. 7 minus 5. Okay, divided by the average 6, and you square. So you're going to get 0.11. So it's going to be 0.11. Do you want to try for B? Anyone want to let me know the answer? Anyone? I want all of you to calculate. Come on, this is easy. Come on. We feel this, and then we're going to done with our things. Okay. Johari said 4.33. Which one 4.33? Mean. Are you sure 4.33? How can it's got point?
I got 3, doctor.
Yeah, I got 3 also.
Okay. So 3. I will take 3. How can usually you're going to get this single digit. Okay. Hopefully you're going to get single digit. Just recheck if you got a point and things. But if you calculate 3-4 times, you got point, then you just round it to the single number. But you should get this one. So variance. So Jari said 1, but just wait for your friends to confirm the answer.
0.44.
Okay, it should be
0.44.
0.44. Okay, 0.44. So who get wrong just now, recalculate. Because this error may happen later on, maybe in your quiz, maybe in your, you don't have final, right? You are lucky. In your assignment or in your test. Okay, what else? See?
4.
4. Okay, here
1.
1. D. So please, everyone, try to take this opportunity to try to calculate so you know how to use the formula. It's basically you don't need formula if you understand the flow. How about D?
Sorry,
2.
doctor, I got a question.
Yes.
Actually, for the means, right? If I calculate 1 plus 2 plus 3 divided by 3, I still get the answer. So is it do I mean, can I just straight away calculate the means and
Okay,
then use
can you do the same for A?
wait 6 plus 7 divide yes, still get the same answer, just plus the O plus M plus P divided by 3, still get the
Okay,
mean.
okay. The formula is this. Okay, I don't know if you get consistent, if it's work for you. I'm just wondering if there is any occasion that it's not going to work.
Oh, okay.
But it sounds logic. Means that 5 plus 6 plus 7 divided by 3, right? But the formula been given, okay, it should be 4 times of most likely time. So just stick to this.
Okay.
Although that is works, maybe you can use it to later to check if it's going to be really consistent until to the end. Maybe it's going to be your check and balance for your calculation. But for answering the purpose, please use this.
Okay.
Okay. Thank
Okay,
you for your clarification. So I missed out the information in the chat box. I couldn't refer. So maybe got what we have missing here for D variance.
I got 0.11.
0.11. How about E mean duration?
Doctor.
3.
Yes.
And the variance?
1.77.
1.77. Okay, or 7.78. Okay, so you should get this. Okay. So you should, so we are done with the mean duration and also the variance, right? The same thing here, the same thing here. Okay. So when we are done with this is the information that we are going to use to draw our network diagram. Okay. Did you get it? So you need to get the mean duration using this formula. And this would be the expected time completion for each activity that you are going to use to draw the network diagram. Okay, so I don't want to draw the network diagram here. So I believe you should be able to draw later on. Okay, you can check, but this is just for the example of the purpose of the example. So did you get what how to get this mean duration, right? So this is what you're going to use. Okay. So next, what I want to introduce to you is, we also going to ask you, you should be able to know the probability of completing the project within certain time. For example, they say, I want to know in this project, let's say in this project, what is the probability of completing the project on or before 22 weeks? Okay. So here you need to calculate the sigma. Sorry, the Z, the probability. So what you should know, you need to solve this question, you need 3 information. One is activity on critical path, okay, mean duration, and variance. So why they ask you to calculate the variance just now, okay? So you got the variance here, right? And then activity on critical path. How can you know the activity on critical path? Hello? Hello guys, come on. How?
The ones that have the least slack, sir.
Yes, means that you need to draw the network diagram, you need to do the assessment of forward pass, backward pass, you calculate the slack. Which slack 0 you're going to identify it as activity on critical path. So you need to identify what are the activities. Okay, so let's say okay, just take this. So let's say you have draw the network diagram, and then you find out the activity with 0 slacks are C, F, H, and J. Okay, and you took the mean duration and also variance that you have calculated before. Okay, where did you get this from? Hello. So is that good to be silent? Where did we get this from? The mean duration and variance? Gajendran.
Oh, from calculations
Okay.
from the formulas.
Okay, thank you, Daniel. Yes, Gajendran, are you there?
Yes, sir.
Yes, I'm asking where we get this mean duration and variance information from.
The expected time, the short time, estimated time, and the longness time.
Okay, so you got the average, right? So we calculated it before. Okay, how about variance? We also calculated before, right? The table here, right? We just extract CFHJ, C, CF, CF, H, J. Okay, so we have extracted this information. And of course, only for mean duration and also the variance, sorry. This and this, right? So we take it, we extract the information in this table, and then we calculate the total and also the variance. Okay. So for us to calculate the probability, okay. So here, this is the formula, right? So I don't want to repeat the statistic things. You can go and recheck your statistics knowledge. Basically, we want on or before, right? So what is on or before? On or before? Equal or smaller than this. So here is variance, but what we need is, based on the formula, is sigma, right? What is 22 here? So this 22 is
Weeks.
weeks. Okay, on or before this. What is this? Mu. What is mu?
Total mean.
Total mean
Here.
duration.
Here. Okay. And sigma is the only thing that we need to do some calculation. Why? Variance is sigma square. So we got 4.78. So you need to square root. You got some value here. 2.19. So this 2.19 is from sigma. So you're going to get something, okay? P probability is that sorry. So 2.28. Did you get it? Can you calculate 22 minus 17 divided by 219? Did you get 2. What did you get?
2.28.
2.28.
Yeah, is it exactly 2.28?
2.283.05023.
Okay, so you're going to get in decimals, not sure how many places, but it's better for you to round it to 2 decimal places. Okay, so in this case, 2.28. So what's next? You need to refer to the normal distribution table. 2.28. Okay, 2.2 here, 2.2 we are done, so we have 0.08. 0.08 is here. Okay, so we know is 0.9887. So if you've been asked this kind of question, they're asking you what are the question just now? What are the probability of completing the project on or before 22 weeks, right? So don't just leave like this, okay? So you need to write the conclusion. So you need to write the conclusion, okay? At least, therefore, the probability of completing the project on or before 22 weeks is 0.9887, or you can convert it into the percentage, 98.87%. And you are done. Okay, so till this point, is there anything that you think is not clear? Okay,
Sorry, doctor, I have a question to ask.
Yes, please.
May I know why we choose the 4 path? Is it because they are critical path, right?
Sorry, why?
Why we choose the 4 path just now? For calculating this probability.
So this one I just give the example.
So just randomly pick for that.
Sorry?
For this example.
Sorry.
So just now, doctor, you just randomly pick these 4 activity.
Yes, this is just for calculating example. In your case, okay, I give you exercise. This exercise you try to do, and then you are going to develop the network diagram. And from that network diagram, you are going to identify the critical path. For in your calculation, for this, okay, for this, you choose the critical path from the network diagram. I don't want to repeat the network diagram in this example. I just want to show, let's say you have drawn, you have calculated, you have identified, then you just pick up. Okay, let's go to our example. Here, what's the critical path in this? A, B, F, G, H, right?
Yes.
A, B, F, G, H. So you can just choose A, B, F, G, and H and take the value here. But of course, this is not the PERT. So this is example. In your case, later on, you need to draw, you need to identify, and you need to extract from them. So in this slide is just an example. If you identify, then how you're going to get it. Okay?
Okay, understood, doctor. Thank you.
So I will give this exercise for you to develop the network diagram. Do you want to try, or I don't want to wait? We are done actually. I just want you to, can you do it? Can I assume this as a take home work?
And
Okay, I just don't want to wait for you to calculate.
Yeah.
Okay. So calculate the expected time, the variance, and then try to develop the network diagram. Okay? Okay or not? Not okay.
Okay, doctor.
Okay. Okay. Seems, all of you are tired. I don't know why. Okay. So if you don't have any question, we are done. Make sure you try this exercise. And then what else? Got the information about, sorry. Yes, Daniel.
Sorry, Johari is asking, is expected time equals to means?
Equals to?
Means.
Means, yes. Yes. expected time. It's average time or mean time. Yes, the same. So this expected time that we are going to use in constructing the PERT diagram. So what's the difference between PERT and the CPM or the previous network diagram is we are considering these three items. That's all. And it's additional calculation on probability things that you can refer back the slides. I'm going to upload the slides and I have recorded the session. If it's okay, work properly, then I'm going to share in the into the ULEN as well. Okay, I want to ask just now, have you got any information about the midterm test?
Yes, doctor.
Yes, what was the information that been
Project
informed to you?
management, 25th April.
Okay, how do you get it? Get the information? Is it me who?
From FKP Facebook.
Okay, so 25th, the location?
Dewan Chancellor.
Okay, time?
It just stayed in the morning.
Okay, so it should be around, we are at 9, should be at 9. So just be prepared for the, I don't know, you still have time, right? 25th means that 2 weeks to go. Okay, 2 weeks to go. And the question will be on this chapter, okay, on network diagram. So that's all that I can share. Okay, thank you.